So guys, yesterday we have done the lab on our active passive scenario. Now today we will discuss what is active scenario. So first of all, just remember one thing. Either you are deploying Palo Alto Firewall in active passive, or either you are deploying Palo Alto in active mode. There is no increase in the throughput. If that's in that case, your throughput is 100 Mbps, then in active scenario also 100 Mbps. So there is no increase of 1 MB. Okay, throughput is similar. Now you can ask, then what is the benefit of deploying this firewall, Palo Alto 5 and active? Generally, recommendation from Palo Alto, they just say do not go for active deployment until you are having a requirement. Now, so Palo Alto just created this active deployment to support the asymmetric routing. If you are having environment where you are having some asymmetric routing, in that case only just go for active scenario. Otherwise, we don't require to go for active. Always we will go with the active passive mode, because when you deploy firewall in active mode, it's become very complex to basically configure your net rules, configure your policies. It's become very complex, and you come across lots of situations where your users are not able to basically not able to access the internet. You will face multiple challenges as well. So it is also not a recommended solution from Palo Alto as well. Okay, they always recommend go with active passive, and because the thing is there is no increase in the throughput as well. So that is also one of the reason. Now what is asymmetric routing, guys? So let me just explain what is asymmetric routing, because this Palo Alto developed this concept how to support the asymmetric routing. So let's suppose you are having this kind of setup. I am having my firewall one. Okay, this firewall have a connectivity with the ISP, maybe one of the router here, as well, and these router have a further connect with the internet. Okay, so this is your WAN zone. Same thing you are having in LAN as well. You are having one more router here, maybe router R3, and you are having router R4 here, and here you are having your LAN zone. Now let's suppose you are having one server here. This is your server, and maybe you are having one more server here, or maybe you are having few LAN users here. Now let's suppose when these LAN users, they are trying to access the internet, so they are just communicating like this. Their traffic going through this router R3, hitting to the firewall, then firewall forwarding this traffic towards R1 and going till the internet. Now when your return traffic is coming, it is coming via R2. So that's the problem now, because see, my firewall send this request packet through this interface Ethernet 1/1, 1/2, 1/3, and 1/4. Let's suppose. Okay, so now my firewall just forward this packet through this interface. Now he's expecting the reply from the on the same interface, but he is receiving the reply into some different interface. What it will do? It will drop the packet in that case, because he's expecting the reply here, but he's getting the reply from this particular path. So this is the scenario of asymmetric routing. Means our traffic going from one, we can say one direction, and coming back from the some different direction. Means firewall forwarding this traffic through Ethernet 1/1 and receiving the reply on Ethernet 1/2. So because whenever this packet go, it will do the TCP state check, and in this TCP state check, it will drop that packet. So to support this particular scenario, they have created the active deployment, guys. Same thing. If I'll take another example, I'm having one PC over there. Now let's suppose I'm having this server. So my traffic going into your firewall through this interface, and it is just going till this server. Now when reply is coming, reply may be coming through R4. So this traffic firewall has forwarded from this interface, and so he will expect the reply on the same one, but he is getting the reply into some different interface. So this is also a asymmetric kind of environment. In that scenarios only we will use we will deploy firewall in active mode. So what happens? How this particular active scenario resolve this problem? What you have to do? So let me just upgrade something. Okay, so now let me just put one more firewall here. Come on. Yeah. This is my firewall 2. Now this firewall have a connectivity with this router, and this firewall, this R4 have a connectivity like this. Here we are having R1, we are having R2 like that. And they are having connectivity with one of the link through HA3 link. There is a HA1 and HA2 is already there. Okay. But in basically active mode, we do have a HA3 interface. So now what happens? Now whatever traffic will go from here till here, and when reply is coming, so what reply received by on this firewall, and what this firewall will do, he will just forward this reply through HA3 link to firewall 1, and now firewall 1 basically process the packet, and he will just forward this packet till here. So like that, basically it will resolve the problem of your asymmetric routing. Now whenever, because now when this firewall 2, he will receive the packet on this interface, he will not drop. Okay, he will not drop that packet. So that's why they have basically designed this, develop this active concept. Okay, now coming back to here. So basically in active scenario, what happens? We are having Palo Alto 1, we are having Palo Alto 2. Both firewall can do the data forwarding, means they can, if both can able to share the load with each other. We need a HA1 interface, HA1 backup. So HA1, so sometime what happens, guys? Sometimes you will see HA1A. This interface denotes your HA1 interface. HA1B, which means this interface denotes your HA2. And we do have a HSCI port. This HSCI port we will use as a HA3 interface. Okay. So devices back each other, taking over the primary ownership if other one fails. Both devices in the pair are actively processing the packet and passing the traffic. They will do the load sharing. If you see at this, no increase in the session capacity, means there is no increase on the throughput. Not designed to increase the throughput. This particular thing is not designed to increase the throughput as well. Virtual wire and layer 3. So when we can deploy 2 firewalls in active mode, so we can either deploy in virtual wire mode or either in a layer 3 mode. See, this deployment is recommended only in the environment with the asymmetric routes. So if you are having environment where asymmetric routing is there, go for active. Otherwise, we don't deploy firewall in active mode. Okay. This is this information is set by the Palo Alto main document, main Palo Alto architecture document. I have taken the screenshot from there. Now, HA3 interface. So basically, why they will have a concept of HA3 interface. So let me just tell you. So if I'll go over there. Let me open this one. So guys, in active mode, we have introduced this HA3 interface, and we will use this interface. So sometime what happens in basically active scenario, there is two things we have to know. We have to know the concept, what is session owner, and we have to know what is session setup. So what happens whenever they will receive, when this device receive the traffic, what they will do? Now they will decide who become the session owner and who become the session setup. Now, if you want to see what are the job of your session owner, so let's suppose I have sent some traffic, and this device become the session owner for this particular packet or for this particular session. So he becomes session owner. Let's say this firewall to become the session setup. So now all your layer 7 inspection like app ID, content ID, evaluation of security policies and log traffic, it is done by the session owner. Means who become the session owner, he will do all these things. Means he will do the app ID and content ID, means layer 7 inspection. Now who will do the session setup? So who will become the session setup device? He is responsible for doing your layer 2 to layer 4 processing. So guys, in packet flow we have discussed this in session setup state, right? So what are the things we are having? We are having routing checks here, right? We are having net policy evaluation, security policy. So all these things done by the session setup device. These things we have to remember. So basically in interviews also, if they will ask what is session setup, so and what is session owner? So session setup responsible for layer 7 processing. It will do your application identification, your content identification, your thread scanning. Session setup, he will perform your layer 2 to layer 4 activities like routing, net, zone protection, quality of service, BPNs, all these things done by the session setup device. Okay. So this is the concept of your session setup and session owner. Now let me just go through the lab and I will cover the remaining things during the lab. So guys, I will use the yesterday lab only. Only the thing what I have done, I have just added new interface which is Ethernet 1/7. That interface I will use as a HA3 interface. Okay. So now I'll go into my firewall. I'll go into my network tab. See Ethernet 1/3, 1/4, 1/5, and 1/6 already in a HA type interfaces. So I'll go into Ethernet 1/7 here. And I'll just change the type of this interface as HA and give the name here HA3. Click on OK. Go to into device now. Go into firewall 2, do the same thing. Configure Ethernet 1/7 as a HA interface. HA3. Type is HA. Make this interface up. Now go to into your high availability, go to into path monitoring, link monitoring. So I'm just disabling this path monitoring and link monitoring, guys, not required. Okay. But in production you have to configure, but I'm not. I'm just disabling these things. Okay. So you know the concept. So if you are working in a production, you can able to configure them. Okay. If I'll go into journal, so if I want to configure right now, my active passive is running, right? So now I want active deployment. So I'll go to into this gear icon. I'll give the group ID 50. So I will use same group ID. And this time I am going with the active deployment. What mode is active? So I click on active, click on yes. Device ID 0. So guys, we have to define this device ID in active deployment. Device ID 0. Enable the config sync, and I will use the same IPs from yesterday. This is the IP I'm using in my firewall to HA1 interface, and this IP 1.1.2.2 I'm using in my firewall 2 as a HA1 backup IP. Click on OK here. These things is already there. We don't need to change anything on this settings. These interface needs these kind of IPs only. So there is no change on the HA1 config, HA1 backup config, HA2 config, and HA2 backup config. No change at all. Go to into the election process. We will always enable permission in active mode. So I'm just enabling device priority is 50. Now, whenever you will have an active scenario, you will get this new tab here. So now active config, do the active config, click on this. Configure your HA3 interface, which is Ethernet 1/7. I want to sync my routing. I want to sync my quality of service. Tentative hold time is 60 seconds. Now, guys, who will decide and how my firewall will decide? Let's suppose I'm having this kind of environment. I am having my firewall 1. Here are my firewall 2. Now I have sent some packet from here. There is a one PC. How basically my firewall will decide who will become the session owner? So session owner will do your layer 7 processing, like your app ID, your content ID, and who become your session setup. Session setup will do your session setup state latest stuff like routing, route lookup, your net policy evaluation, your security policies evaluation, your zone protection, like all these things done by this device. How they will basically decide? So guys, generally we will always use here first packet. This is the recommended one. Always use first packet, means device who is receiving the first packet, he will become the session owner. And in session setup, guys, if you see here IP modulo, this is the most important used method. IP modulo method we always use for the session setup. But let me just use here one of the mode, which is first packet. Means what I want. First packet is also used a lot. So now whoever, let's suppose my firewall one received the packet. Now my firewall will do everything. He will do the processing for session owner and processing for session setup. Both things done by the firewall one only, because this decision of session owner and session setup is taking on the basis of first packet, right? So who will receive the first packet, he will do the everything. Now you can ask one question here. Let's suppose your firewall one become session setup and session owner. So he will do the data forwarding, right? Let's suppose reply for this packet may be received on firewall 2. What firewall will do? They are having this HE3 link, right? And so firewall 2 forward this reply through this HE3 link to firewall 1. Now firewall 1 will process the packet. Like that, basically things works in active mode. They will use HE3 interface just for sending the packet with each other. Okay. These are the data packets they will exchange between each other. Click on here. Now guys, you have to also understand one more thing. If I'll go over there, let me do the same config on this device, and after that I'll explain. So I'll go into devices, to general settings. Here I'm using active mode. Click on active. So here basically I will give device ID 1. So in basically primary device, I will give device ID 0. In this one, I will give device ID 1. Remaining things remain same. Go over there, enable this particular permission. Okay, so permission has been enabled now. Go to into active passive. Ethernet 1/7, enable the virtual router sync. So they will able to sync the virtual routers. They will sync the quality of service, and we will also configure a first packet. So these settings are same on both the devices. Now let me explain what is new session, what is packet matching the existing session, and what is asymmetric flow. So if I'll go over there. I'll just open this one, and after I'll just go for the deployment. So guys, if you see here, let's suppose this is the new session. Okay. So this is my PC who initiated the connection, and this is the server on my outside network. So let's say he has initiated the packet like this. Now my device A received the packet. This you can think this is my firewall 1, and this is my firewall. Device B is my firewall 2. So let's suppose this device A, he become the session owner. He become the session owner, and it will basically do the layer 7 activity. And this device B, he will become the session setter. So what happens? So see, now this packet go into your device B for routing, for net, for security policies, all these things done by this device B. Then he will forward the packet here through, and all these packets they are sending through HA3 interface only. Now this device do the app identification, content identification, and he will forward the packet towards the server. This is how your packet traverse, guys, in that case. Now in our case, basically we are using session owner and session setup on the first packet. Means same device will become the session setup and session owner, so he will do the everything. Okay, he will process the entire packet for all the processing. Now this is the packet matching an existing session. So let's suppose we have received the packet. Now, because see, this device is a session setup device, right? He will do the session setup, but we are receiving the packet for existing session. Means now this particular packet we don't need to send for the session setup state, right? So this packet will not go to your firewall, to a device B. It will directly forwarded by the device A. Just remember this thing, guys. Okay, so this is how they will handle the existing session. Now asymmetric flow, this is the flow, guys, where we required, where we have asymmetric routing. Means what happening, our packet going here on device B, then it is going till this server. This is a session owner and this is the session setup. And if you see here on this one, this is the session owner and this is the session setup. See, if we have received the packet on device B, see that packet come to your device A, device A process everything and he will forward that packet back to your device B, and then your packet go for your server. So this is how your asymmetric routing it will support. Means if I'll basically draw here one diagram, let's suppose I'm having this setup. This is my firewall 1. This is my firewall 2 here. This is R1. This is R2. And this is my LAN zone. And here I'm having one server. We are having connectivity like this. They are having connectivity like this. This is your WAN zone. Let's say there here I am having one user. Now let's suppose this user trying to, and we are having HA3 interface as well. I am not denoting here HA1 and HA2. Now let's suppose this PC wants to access this server. So he will forward the packet, maybe in so packet coming to your firewall 1, he will forward this packet till this server. And let's suppose firewall 1 is your session owner and he is also a session setup. Okay, both things is done by the firewall 1 only. So now because we are having asymmetric routing here, means when this server give the reply, that reply come to your firewall 2. So now what it will do, this firewall to forward this packet to firewall 1. Now firewall 1 process the packet according to your life of a packet, and he will forward reply here, and that reply go like this. So this is how basically it will support the asymmetric routing, and this is the only use case you have to remember while you are going for the interview. Now there's a one more thing we have to discuss here. Basically in active deployment we can deploy in two modes, either in layer 3 mode, either in virtual wire mode, right? So we are having two mode of deployment. Either we can go with the floating IP and either we can go with the R float sharing. Floating IP address and virtual MAC address move between the devices on failover, supports VPN and NAT implementation. In that mode it will support your VPN and NAT implementation. Can use external load balancer to spread the traffic across the devices. Okay, so in basically floating IP mode, what happens? So let me just open one diagram here. This is the floating IP deployment. If you see here in this deployment, why we are having Palo Alto 1, we are having Palo Alto T. So this interface and this interface, they are having dedicated IPs. These in black color, these are the dedicated IP address we are having interfaces, and they will also need a two floating IPs. Same thing in this segment. These interfaces having the dedicated IPs and they are also having floating IPs. These are the floating IPs. Means, and basically in this mode, we have to configure the IP address on the interfaces, as well as we have to configure the floating IPs. Okay, and now these, if you see here, we are having this IP and this IP, right? These are the two floating IP. So whatever host we are having, right? So let's suppose we are having 100 users here. So on 50 users, we will configure the default gateway towards your firewall 1, and on another 50 users, we will configure the default gateway of firewall 2. So means they will be half of the traffic go through this firewall 1, half of the traffic go through your firewall 2. Now just remember one thing. Let's suppose due to any reason your one of the firewall went down. In that case, what happens? Your floating IP address, whatever you are having in your firewall 1, it will move towards your firewall 2. Right now, at that time, firewall 2 will have two floating IPs, and also your virtual MAC address will also go from firewall 1 to firewall 2. So like that, basically this thing work in case of failover event. Okay. So now let me just go through with the deployment so you will understand more. So guys, how you have to do it? So right now, if you see here, I'll go into my network tab first. This is fine. Let me go into this network tab as well. I'm having this IP. Let me just configure the IP address as well here. On this device, we have to change the IP because in floating IP, both device needs the different IPs. Okay. I will use here 116, and on this one, I will also change here. These are the static IP which I'm changing. Okay, so 192.161.116 I'm having on my secondary firewall, 110.1.1.116. Here I am having 192.161.115 and 10.1.1.115. Now let me configure the virtual IPs as well. So I'll click on this one. I'll select my interface Ethernet 1/1, which is my outside interface. I will just configure here IP, which is 192.168.1.250. I will use this IP address at 250. Type is floating. Floating IP bind to the active device. So generally, I will not select this option. I will select here. So I want 192.168.1.250. This is the floating IP address I want on my firewall 1. So I will give here priority 50, and here I will give priority 100. And if you remember, device 0 having priority 50, so means this IP will be active on my firewall 1. Failover address if link state is done. Click on OK. Add one more. 192.168.1.251. 251 I want in my firewall 2. So I'll select, I'll give here 100, and I'll give here 50. Means whoever having less priority, because device 1, it's my firewall 2, right? So I want this IP on my firewall 2. Click on OK. Click on OK. Add another interface, which is Ethernet 1/2, and add the same thing. 10.1.1.250. This IP I want my firewall 1. So I will give here 50, here 100. Configuration is very easy, guys, for this setup actually. 10.1.1.251, 100, 50. Okay. Okay. And we have done the settings here as well. Now just do and go for commit. Hit commit here, hit commit here as well. Meanwhile, let me go into my topology. So first I'll go into this. Inside router, let me open this one. So inside again, I have to open the outside one. Let me open this router. Let me open this router. Now what I will do, On this router, actually, I will configure the default gateway, which is 10.1.1.250. So he will forward the packet towards this firewall. And on this one, I will configure the default, which is 10.1.1.251. So he will forward the packet towards this one. Now, guys, just remember one more thing. Now we have to configure the PAT rule, right? So we will always configure the PAT rule on floating IPs. So we have to configure two PAT rule, one here, one here, and we will use here floating IPs. Okay, so I'll show you that part as well. Meanwhile, so error net rule. Okay, there is some issue with our PAT rule, guys. Okay, so that's why this commit is failing. So just go to into PAT rule. I just added this PAT rule here. Same thing, translate IP. I will use this time. I will select a floating IP and I will use the floating IP, which is, or do one thing, just delete this PAT rule. Okay, not required for now. Just delete it. Just go here and delete the PAT rule from here as well. We will configure the patting later. Just do the commit now. Do the commit here as well. And meanwhile, let me also configure my remaining part of my topology. I go to my inside. Conf T. So I have introduced one more interface, which is interface gig 0/3. Switch port mode access. Switch port access. VLAN 99. Switch port host. Exit. Do so run section IP route. So guys, this is the command I have run. Okay, do so run section IP route. I will just remove this route. And I will also point this route towards my firewall one. Save the config. Go to into R1 router. Do so run section IP route. Just remove this route. And we will point towards firewall one on this one as well. Now let me go to into R2, and on this router, I will basically point towards my firewall 2. And we will check the things. Enable conf T, host name is inside R2. Interface F0/0, no shutdown, and IP address is 10.1.1. Use here 160. Use here 161.255.255.255.0. No shutdown. And IP route 0.0.0 towards 10.1.1.251. These are the settings I have to do with regards to my R2. Commit has been succeeded. Commit has been succeeded. If you go to into dashboard. So right now I'm having here, this is active primary. This is also active primary. Tentative link is down. So I think there is a one link is down. So let me just see what is the link is in down state. Active primary and active primary. So this is, they are basically going in a split brain situation right now. So let me go into this one. First, I will just suspend this device. Okay, I'll just check these settings are fine or not. Okay, so everything is fine here. Link and path monitoring. So I think this is enabled. That's why we have to disable this one on this device as well. Let me delete it. Do the commit now. We'll wait for this commit to complete. Meanwhile, let me also do one more thing. I'll go into network tab. So I'm having these IPs here. Into this device, I am having these IPs. So IPs was wise. I'm good here. Let me see the status of the interface. Advanced. Make this interface up manually. Make this interface is also in up state. So you have to do it manually. Okay, this is already in up state. Just wait here for some time. Let me just make local device functional. Let me see the status here. 192.160.137 is active primary. This is waiting for it is in hold time. So we just wait here. Just click on manual sync. Synchronization is in progress. So we have to, okay, synchronize now. So now local device is active primary and other devices in active secondary. Things are fine. Active secondary and other one is active primary. So this is my firewall 2, which is in active secondary mode. Okay. Interface is still in down state. So let me just see. Yeah. Its interface is also in up now. Let me go here. Yeah. It's came up now, right? So if you see here, I'm having these IP address on this one. Now I'm having this IP address on this one, right? If I'll go over there, if I run here one command, so high availability virtual address. Now you will see on this device, this is my firewall 2, this is my Ethernet 1/1. This IP address is not active on this device, and this IP address in active state. This device is active in this one, and other IP is not active, means other one active on other one, right? On my firewall one. So if I run here, so high availability virtual address, you will get it. See, this IP is active on this, and 10.1.250 is active on this device. Now do one thing. Go to into your policies and add your net rule. So we have to configure two pet rule, guys. Pet rule 01 for firewall 1. Same thing. Inside, going towards outside. Interface is this. Any address translated packet is dynamic IP and port. We will use your interface address. This interface, floating IP, and use this IP address. Active to binding. I want this IP address on the firewall who is having 0 binding, or you can also select a primary if you want, but I will select on this one. Add another pet rule here. 02, same thing. Inside zone, then outside. Interface is this one. use at 251, and this particular patrol I want on my firewall 2, so I will use here 1. So 0 is for firewall 1 and 1 for firewall 2. Like that, we have to add our pet tool, do the commit. Just wait for this commit to complete, and when your commit will complete, that time if you go over there, and we will just try to take the SHS of our outside switch. Telnet, so I'm taking the SHS from my R1 192.168.1.99. I think that's the IP. Yeah, so I got the access, username Cisco, probably Cisco. I've got the access of my out switch, right? If I'll go into my firewall, primary firewall, if I run here one command, so session all, there is a one telnet session, show session ID 17. This is the client to server flow. This is the server to client flow. See, this pet net rule is, it is matching pet rule 0. Application is telnet and rule is allow all. Session owner is true. Session setup is true. Means if you see it, this is the device who is also acting as a session owner and is also acting as a session setup, because we are using here first method, first IP, right? We are using first packet. Now do one more thing. If I'll go in my R2 router, same thing. I'll just do the telnet on 192.168.1.99. Let's see what happened. Cisco. Cisco looks like I have entered the wrong password. This time it is correct. Now you will see one more session here now. Show session all. We are having two sessions. Just look for session ID 18 now. Show session ID 18. This time you will see here session owner and session setup is false. On my firewall 1 means firewall 2 is handling this particular packet. So if you click here, show session all, and look for session ID 20, show session ID, because 20 belongs to that particular, see, and this particular traffic is handled by my firewall. So our first packet method is working fine. This is how basically we have to configure this thing. Session owner and HA active local device is true, and session setup locally HA is also true. Okay. Now, let's suppose there is a one thing happened. Let's suppose this device went down due to any reason. I've just shut down this device. See the magic here. You will see your session is still there. So version, see, your session has been not breaked yet, and your device is down right now. If you run this command, show session all right now, we are having all the sessions as well. If you look for this session ID 18 this time, so session ID 18. Right now, see, this devices start handling the session owner. So session setup is not done because there is already existing session, right? So now he's become the session owner right away, because he is basically processing the packet on first path. If you run this console high availability virtual address, you will see right now both addresses are active on this device, secondary device. So this is how when failover happens, you will see there is no delay, right? Your connection is not terminated. Your telnet is still working, right? Now let me just make this device up. When this devices came up, what will happen? It will take the role of active primary. It will become the active secondary. Let's see after some time. But right now, if you see the status, you will see this device is acting as active primary and other devices failed. So this is how basically failover works in case of your active scenario. Now we do have a one more deployment, which is ARP load sharing, guys. So let me explain what is ARP load sharing method and how it basically works. So these are the two main deployment method of your active scenario. So let me just see. Oh, this is the ARP load sharing one. Okay. Now, if I'll start explaining this ARP load sharing, guys, this method is only possible if we are having here layer 2 devices. If let's suppose you are having routers here, you will not able to deploy this ARP load sharing method. We need a layer 2 device. This device should be a layer 2 device. And that time, guys, what is the difference between floating IP and ARP load sharing? You need a layer 2 device here, and also there is only single IP address. There is only single IP address you see here in both the diagram. There is only single IP address, and this IP basically responsible for doing everything. And how these devices they will process the request. So guys, whenever these PC they will send the request, these requests go towards both the devices, but whoever give the reply for ARP, who will handle all the packets. So basically they will do the load sharing on the basis of ARP requests and replies, guys. A single IP address is shared between the devices. A unique MAC address for each interface supporting the shared IP address means this shared IP is activated on both the devices. But they are both devices having unique MAC address. Device respond to the client ARP request based on the source address. Requires a layer 2 connection. If you are having layer 2 connection, then only basically this deployment works. That is the prerequisite. Okay. Apart from this, let's just wait for this particular device to come up properly. Meanwhile, if I'll go into my devices, active scenario, click here. Guys, if we use this primary option, which means whoever received the packet, always who is a primary active, he is basically handling all the packets. So guys, when we use this primary device option, which means we are deploying active passive. In active mode, we are going with the active passive thing. So that's why we don't use this primary device option. Primary device option means who device. So we are having two devices here, like firewall 1 and firewall 2, right? Firewall 1 is your primary active device. And this is your primary, we can say secondary active device, or we can say active primary, and firewall 2 is active secondary. Now active primary device means whoever a primary active device or active primary, he will do all the data forwarding. So this method become a active passive deployment. So we don't use this method, guys. So always decision for session owner is taken by the first packet, but sorry, always we will take the decision of a session owner on the first packet, but session setup we always use some different thing. First packet, the most important algorithm is IP modulo. We always use IP modulo here. Okay, so if you want to see Palo Alto active HA, if you will Google it, what is the algorithms for active scenario? So this is the configuration method, guys. I'm just looking for the algorithm types, guys. Okay. First packet means the firewall that receive the first packet of a new session is become session owner. Recommended setting means this is the recommended setting by a Palo Alto. This setting minimize the traffic through the HA3 link. Why we will make? So basically it will minimize the packets which we are sending through HA3 interface. Primary device. The firewall that in active primary state is the session owner. So we don't use this method. For session setup, select the following IP modulo. The firewall performs an X or operation on the source and destination IP address from the packet, and based on the result, firewall chooses which HAPR will become the session setup device. So this is the meaning of your IP modulo, which what it will do. It will take your source IP, take your destination IP, and perform the XOR operation. Now, after performing this XOR operation, if value come as a even value, which means your firewall one handle the packet. If value coming odd, then your firewall to handle the packet. Like this, like that, it will basically make the decisions. Primary device. The active primary firewall setup all the session. First packet, the firewall that received the first packet of a new session performs as a session setup. This is the recommended setting. See, that's why I have explained these settings. Start with first packet for session owner and session setup. Then based on the load distribution, you can change one of the other options. IP hash. The firewall uses a hash of either source IP address or a combination of source and destination IP address to distribute the session setup responsibilities. Means what it will do, either it can calculate the hash of your source IP, or it will use the it will calculate the hash on the source IP and destination IP. These are the basically meaning of these algorithms, guys. If I'll go into use cases, these are the two use cases. If you go through here, you can check out these things, guys, and they will explain you. Floating IP address and upload sharing. These are the two methods which we are having. We will use when we are having route based redundancy, then only we will go for this method. Okay. So let me just change the value. I want to use IP modulo this time. Here also let me log in. If you see here, see, local device is active primary, other device is active secondary, but this rule will change after some time. Because we have selected the preemption option. So that's why preemption is required in this particular method. Wait here, let me also change the algorithm and we will do the commit after that. So generally always people use first method, but let me show you IP modulo. You will not able to see much thing using IP modulo because it will just calculate it will do the XOR operation on source and destination IP, and it will do the load sharing. Let's do the commit here as well. See, local become active primary, other become active secondary due to the preemption. So always basically whoever you will configure as active primary device, he will take the role of active primary because we have enabled the preemption. That's why preemption is required in this particular method, guys. Remember this thing. Just wait, after commit, basically this thing resolve. So whenever you will make any changes with regards to your algorithms and all, just make sure basically you are doing the commit at the same time. It is in 99% still completed. So you will see they will converge the HA after few minutes. It is in a tentative hold time. So basically they are having some hold time value. So after 1 minute, I think 1 minute is the value. After that, this it will act as active primary. This will become active secondary. Let's wait here for some time. Meanwhile, yeah, they have converged now, right? So whenever we are changing anything, we will do the changes at the same time, guys. Now, this time if I'll basically take the SHS of my outside switch, Cisco, go here, go into firewall, show session all. There is just 23 session ID, show session ID 23. You will see session owner is false, session setup is false, means this particular traffic right now is handled by your firewall 2, firewall, I think firewall 1. Yeah, firewall 1 is handling this session. So where is my all the session? Let me open this 10 as well. This is firewall 2, and he is neither a session owner, neither a session setup. If I'll go here, let me also do the telnet from this R2 device. Telnet 192.168.1.99. Hit enter. Cisco, password is Cisco. So session all, look for session ID 25. Sometime you will see session updated by the pair. Okay, so for this traffic, session owner become your firewall 2, but session setup is your firewall 1. So this is how basically whenever you will change the method, they will basically do the load sharing, guys. Show session all. We are having 2 session. Look for session ID. Show session ID 4. Let me look for 4. So see, session owner is true and session setup is true. So for this one, traffic who is coming from this machine is handled by this device. But if you will look for the session ID 5, if traffic coming from this machine and going to this, session updated by the peer true, session owner is false, session setup. So session setup done by this, and the session owner setting done by this device, right? So like that, they will do the load sharing, guys. This is your one of the method, which is IP, or basically IP modulo. Now, if you change this method to hash, if you click on hash, you can select you want a hash of source or source and destination. So I want hash on the source IP. To commit, go here and change the method. So like that, you can change the method and you can basically test the things. Use your source, but recommended is destination, source and destination. Okay, totally depends on how you want to deploy, but the best way you can go for first packet. Wait for this commit to complete, and after that we will see. So let me exit out from here, and let me exit out from here as well. Let me clear all the session from both the devices. Clear, come on. Clear session all. Cleared. Clear session all. All the session has been removed now. Let's wait for this particular So generally, because these are the BMs, so that's why it is taking some time in converging this topology. But in hardware devices, it happens so fast. It's very quick actually. You will not see this particular error message. Go into device. You can also reduce this time a tentative hold time, right? Disable the tentative hold time functionality. So if you will disable that time, they will not wait actually. Go here and just disable this particular functionality totally. So like that, you can basically modify the settings, but always go with the as per the Palo Alto recommendation. Okay, don't change these things. But this is our lab environment, so we can do in our lab environment, right? We don't have any problem here. Wait for this commit to complete, and after that, I will basically go towards your R plot sharing method. $99. This is also $99. Okay. This device active primary, another one is active secondary. Now again, go and initiate some traffic from this host. Cisco. Initiate some traffic from here as well. Cisco. Go into your firewall sessions table, show session all. We are having two sessions here, 7 and 6. First open session ID 6. Session ID 6 is from your R1 router. Because R1 having this IP 10.1.1.150. So if you see here, session updated by HTTP false. This device is handling both things. He is the session owner and he is the session setup now. Look for the session ID. I think it was 7, right? Yeah. Session owner is false, but session setup is locally. So like that, this basically they will choose. Okay. That's why I always go with the first packet because that's the recommended one. Okay. Now let me quickly go through with the R load sharing deployment. So just exit out and exit out. In R load sharing, guys, you don't need to do much thing. What we will do. So let me tell you before going to R load share, guys. In production environment, we are having mixed mode. Okay. Maybe in WAN side generally, we will go with the floating IPs, and in LAN side, we will go with the R load sharing, guys. So what I will do, I'll go with the R load sharing here, and when I will just go with the floating IP. Okay. How you can do that? So you have to go to into your firewall, into devices. This place only, go to into Ethernet 1/1. So not required 1/1 because this is already in floating IP, but I want R float sharing in my this end. So what I will do, I remove this IP, I'll go inside this IP. I want R float share now. Device selection algorithm, IP modulo, IP hash. I want IP modulo. (10.1.1.250). This is the IP address. Do the commit. Done. We are done with the R float share. This is the only setting you have to change to configure the R float sharing method, guys. On the firewall perspective, just wait here. And you will see these settings automatically will synchronize here after some time. Just wait. So it's a mixed mode. On WAN side, we are having floating IP. In LAN side, we are having R float share. So 99%, just wait for 100. See, setting has been applied, configuration is succeeded. Now you will see we are having upload share in downstream. Now we have to also make some changes on our these routers, right? On this router settings are correct. Do so run section IP route, because we are having this thing, right? Route is correct, but on this one we have to update the route. Do show run section IP route, because in our plot share we are having only single IP address. We have to remove that route and we have to add the route towards the that IP only, because we are having only single IP this time. And we are done with the R plot share here. This is how we can configure the R plot share, because see, on default gateway on both the machine it's same shared IP address. Right now, both firewall are sharing the same IP. If you run this command, so high availability question mark virtual address, it is active. Yes, we are using our plot share. This is the MAC address on this one. Go into other one. So high availability virtual address. It is also active in this device. This is the MAC address. So you will see the difference in MAC address. This is 50.0.0.0.0.0.2.0.0.0.2, right? And if you go here, this is 0.1, right? So that's the difference. Now, if you go on my R1, if I just do the ping 192.168.1.99 with repeat count of maybe 100, do ping 192.168.1.99 with repeat count of 200. Ping is not working. On 92.161.99, okay, that's correct. Let me just do the telnet as well from here. 192.168.1.99 Cisco and Cisco. Password is Cisco. Now I have got the access. Let me, yeah, see, ping has worked after some time. See, ping is working. Sometime maybe there is, it will take some time to converse the topology, right? Let me do the telnet as well. Do telnet on my 192.168.1.99. Type here Cisco, type here Cisco, and we got the access, right? Now just go here and just run one command, show session all. We are having one session from R2 and this session from R1. So just look for show session ID 302. Session setup and owner is similar, right? Now look for another session ID which is 503. Same device. So guys, right, for this traffic, either it is coming from this machine or this machine, he is doing the, or the, he is basically taking care of all the data forwarding. Okay, now let me also see one more thing, because they are calculating the hash. Now they are basically taking the decision on the basis of that hash value. Okay, if you go over there, if I let's suppose I want first packet and I want also first packet here. Do the commit. I'll go into other one. I will change here first packet because that's the one which we will always use. Okay. So like that, you can also test these multiple possibilities, but always go with first packet. And just or what I can recommend, guys, until there is a asymmetric routing, don't deploy your firewall in active mode. Because see, I'm having experience, like if you call to Palo Alto tech, these tech people also, they will afraid of basically picking that kind of cases with regards to active because these are the most complex things, because in production environment you are having two firewall running on active mode, they are having multiple virtual systems, multiple virtual routers. It's becomes too much complex things to manage. Okay, so this is, guys, your upload share method, and this is how we have to configure it. Now these things you can basically check and you can test changing these methods and all, but the recommended one as per Palo Alto, you have to go for first packet based.